Welcome to Homework Lib.
In this case, we're going to have 2 moles of ice with an initial temperature equal to minus 30 degrees Celsius. And we want to transform it into steam at a final temperature equal to 140 degrees Celsius. And we want to make the heating curve to show the process described over here with the accurate amounts. So the curve of temperature versus heat provided to the system is going to look like this. Initially, we're going to begin at the point of minus 30 degrees Celsius with 0 joules. Over here, this is going to be joules, and temperature is going to be in degrees Celsius. The first thing that is going to happen is that the temperature of the system is going to rise until we reach, let me put it a little bit more to scale, because this is actually quite close to 0 degrees Celsius compared to the other. First of all, temperature is going to increase from here to this point. Here we're going to reach 0 degrees Celsius. We're going to start to have some melting at constant temperature. When we have melted all of the ice, then temperature is going to rise again all the way to 100 degrees Celsius. Then temperature is going to be kept constant again for a while. And finally, temperature is going to rise whenever we have vaporized all of the water until we reach the temperature of 140. Let's put it around here, 140 degrees Celsius. And this would be our final point. So this would be the shape of the heating curve for this experiment. Now what we want to know is what would be the different points on the y-axis that we should label on this section. In order to do that, the first amount that we require is heat that is going to be absorbed by the ice. This is going to be equal to mass, heat capacity of the ice, times delta T for the ice. The mass of ice, since we have 2 moles of ice, this is going to be equal to 36 grams of ice. Whoops. Because each gram is going to be 18 grams per mole. So this is going to be 36 grams times heat capacity of ice that is provided by the problem, which is 2.108 joules per gram degree Celsius, times delta T for ice. This is going to be 30 degrees Celsius. This amount of heat is equal to 2,276.64 joules, which is approximately 2.28 kilojoules. So on my y-axis, on my x-axis over here, the first point would be 2.28 kilojoules. Next up, we want to consider the heat that is required to melt all of the ice. So we're going to require 6.01. This is going to be heat coming from melting. It's going to be 6.01 kilojoules per mole times the amount per mole, that is 2. Which gives 12.02 kilojoules. So 12.02 plus 2.28, the next point over here would be 14.3. Oops, for some reason it is not. Here we would have 14.3 kilojoules. Let me change the label here for my axis. This is going to be kilojoules instead of joules, because it is going to be way more convenient. Okay. After we have done this, we can go ahead and calculate the heat that is going to be absorbed by water. This is going to be the same formula, 36 grams times heat capacity, which is 4.184 joules per gram degree Celsius, times the change of heat of water, that's the change of temperature of water, which is 1000 degrees Celsius. This is going to give us 15,062 joules, which is approximately 15.06 kilojoules. So over here, the next quantity that we need to add is our previous result, 14.3 plus 15.06, which is 29.36 kilojoules. Next, the heat required to melt the ice, to the vaporization of water. This is going to be 40.7 kilojoules per mole multiplied by 2 mole. So now in this case, we're going to have 81.4 kilojoules. Thus, our next label over here, it should be way more to the right, but here for sake of space, I'm just going to put the value. You can actually put the graph in a somewhat correct scale with the values that I am providing here to you. So over here, this is going to be 110.76 kilojoules. And here, just to make the graph a little bit more clear, let me put the slope. In this case, it's going to be a little flatter all the way here. And our final point, which would be around here. Now we're going to put the water from the steam. In the case of the steam, we want to change it from 100 to 40 degrees to 140 degrees Celsius. So the change of temperature is going to be 40. The mass is the same, 36 grams. The heat capacity of the steam is 1.87 joules per gram degree Celsius times 40 degrees Celsius. So 40 times 36 times 1.87 gives us 2692.8 joules, which is the same as 2.69 kilojoules. So my final point would be 110.76 plus 2.69. And the final point in our plot corresponds to 113.45 kilojoules. Now, just to label the individual sections, the first part over here is going to require 2.28 kilojoules. The next section, corresponding to the melting of the ice, is going to require 12.02 kilojoules. Over here, on this region, we're going to consume 15.06 kilojoules. Next up, for the vaporization of the water, we're going to require 81.4. And for the final part, we're going to require only 2.69 kilojoules. So of course, all of this is not to scale, but you can put it on the appropriate one with the values that we have provided over here. So that would be all. Thank you very much and have a good one.